Into 1.4, taking a look at a few different ideas about angles. Some of your basic ideas, naming them, looking at a vertex, classifying them. Also working with the idea of what are known as adjacent angles. And these two angles here that you see, angle KLN and angle NLM, are adjacent angles. It says in the opener that they want us to find the measurement of each angle, given that angle KLM is a straight angle. A straight angle means that that angle is a straight line. Any straight line will have a measurement of 180 degrees. So essentially we are taking this angle over here on the left, and we are going to combine with this angle here on the right to make that 180 degree angle. Making our equation 10x minus 5 plus 4x plus 3 equals 180 degrees. Combine your like terms, we have 14x minus 2 equals 180 degrees. Add your 2 to each side. I have 14x equals 182, and divide both sides by 14. 182 divided by 14, we get x to equal 13. Now, the difference is, in this problem, if you look back up at the directions, they want us to find the measure of each angle that is there. So we have to take that and we're going to have to plug it in. When we plug it in, if x is 13, that means the angle on the left is 10 times 13. Whoops, that came out ugly. 10 times 13 minus 5. We get 125 degrees. On the right hand side, it is 4 times 13 plus 3. 4 times 13 is 52 plus 3 gives us our 55 degrees. As a quick double check, these two angles, when you add them together, need to add up to that 180 degrees. 55 plus 125 gives us our 180 degrees. Taking a look at our notes then for 1.4, we're going to go through 1.4 part 1 and part 2 today. Right? Part 1 is just classifying those angles and naming them. An angle are two different rays that have the same endpoint. So here you are looking at those two rays sharing this endpoint A right here. When you name an endpoint, or when you name an angle, typically we'll name it by the vertex that's there. Your vertex is the endpoint of that angle. So here it is, that angle A. The issue comes up, though, if you look at example 1. In example 1, it says name 3 angles in your diagram. We just said that we can name our angle by the vertex. Well, the vertex that's there is angle B. The problem is, if I call this angle B, there are multiple angle B's to worry about. When there is more than one angle at a vertex, such as here, we cannot name it with one letter. We must name it with 3. If I look at our top angle that's here, to name an angle, essentially you need to name it by where you start. Well, I started at point A. Where do you go to? I went to point B. Where do you end? I went to point C. So that top angle is angle ABC. To do our bottom angle, I started at C, I went to B, I ended at D. To do the big angle, I started at A, I went to B, I ended at D. So those are the 3 angles that are there. If I look at this other triangle I have up here, my triangle ABC. I'm allowed to come down to this angle down here in the right corner, my 40-degree angle that's there. I am allowed to call that angle C if I want, because there is only one angle at that vertex. I am also allowed to call it angle BCA if I wanted to, because if I start at B, go to C, end at A, I make that angle that's there. Likewise, we can call it angle ACB, because I can also make it that way. Right? So you have some options in this scenario. Typically, if you can, we will name it with one letter. However, sometimes you will need to end it with 3. Now, when we look at finding the measure of an angle, the measure of an angle is how many degrees are in between the two rays. When we talk about how big an angle is, it is what is the measure of that angle. If you look at example 2, it talks about using a protractor. You guys don't have protractors at home. I understand that. I do want to show you how they work, but you will not be required to use one. Instead, you'll be required to tell how big an angle is. So the measure of this angle here, when I look at it, this angle, it goes through 2 numbers. Up here, it goes through the numbers 67 and 113, depending on if you're on the outside numbers or are you on the inside numbers. Since our angle is bigger than 90 degrees, it is bigger than a right angle, the measure of my angle here is 113 degrees. To use a protractor, we're going to go through the rules for it in case you don't know. To use a protractor, in example 2, it says place the center of the protractor over the vertex of the angle. Step 2 says to align the line on your protractor with one side of the angle. So whether you want to take it and rotate it this way, so that these lines here overlap, or if you want to take it this way. Oops. So that these lines here overlap. It is completely up to you. The other side will tell you how big the angle is. So here, when I follow my line out, it goes through my 140 and 40. Since the angle is bigger than 90 degrees, it would be 140 degrees. Now, these measurements, there are 4 types that you need to worry about. There is an acute angle, which is between 0 and 90. There is a right angle, which is a 90-degree angle. A 90-degree angle must be marked. That is what you are looking at right there with that little box. It is telling you that that angle is 90 degrees. Once you get bigger than 90, we are looking at an obtuse angle, an angle that is in between 90 and 180. And finally, as we talked about in the opener, you have a straight angle. A straight angle is 180 degrees. Take a look at example 2 then. In example 2, I want you to classify those 4 angles. If you want to pause the video to do it on your own, you can. If not, we're going to go through and do them right now. First one is angle WSR. So angle WSR. So if we follow our angle out, we go between 2 numbers. It is either 65 or 115. Since our angle is smaller than 90 degrees, angle WSR is 65 degrees. Second one they want is angle TSW. Angle TSW starts at T, goes to S, then through W. So now we are going through these same 2 numbers, 65 and 115. The difference is now we are bigger than 90. So this angle will be 115 degrees. They did also want us to classify these. So 115 is obtuse. 65, that is acute. Next up is angle RST. Angle RST starts at R, goes to S, ends at T. Here we have our 180 degree straight angle. Which leaves one last one to do. Angle VST starts at V, goes to S, ends at T. If I follow it out, the only number it goes through is 90. So angle VST is our 90 degree, and we call it a right angle. Right, taking a look at part 2. Since we're doing both parts at the same time, you do not need to worry about the little warm-up that's there. We go straight to the idea of what they call angle addition. We did the idea of segment addition earlier this year, where we said if you take these two segments and add them together, if this is 3 and this is 5, then this whole segment AB would be 8. Angle addition works the exact same way. If an angle is split by a ray, then the two resulting angles add to the original angle, meaning that this top angle here plus my bottom angle here, when you add them together, you get the big angle that was there. That is the idea of angle addition. And that's what we'll use here in our upcoming examples. Take a look at example 3. In example 3, it says, given that the measurement of angle GFJ is 155 degrees. Angle GFJ, that's our big angle here. So what my angle addition postulate says, if I take my two smaller angles and I add them together, I should get the big angle that was there. So the big angle they told me is 155 degrees. That means that 4x plus 4 plus my 4x minus 1 must equal 155 degrees. Solving your equation, I have 8x plus 3 when I combine my terms equals 155 degrees. Subtract your 3 over, I have 8x equals 152 degrees, and then we divide by 8. 152 divided by 8, we get x to equal 19. The directions ask us to find the measurement of each of our angles, so we need to take that 19 and we need to bring it up and plug them into both pieces. So on the left, we have 4 times 19 plus 4. On the right, we have 4 times 19 minus 1. 4 times 19 plus 4, we get 80 degrees. 4 times 19 minus 1, we get 75 degrees. So there is the measurement of our two angles, 80 and 75. Same idea then for B. Take a look at B. It says, given that angle VRS is a right angle, that means that this big angle is our right angle. A right angle is measuring 90 degrees. So we need to add our pieces together. X minus 4 plus our 3x plus 2 to equal 90 degrees. Combine your like terms. I have 4x minus 2 equals 90. Add your 2. We got 4x equals 92. Divide and we get x to equal 23. Plugging them back in to find your answers, I have 23 minus 4, and 3 times 23 plus 2. That means that angle VRT is 19 degrees, and angle TRS is going to be 71 degrees. I wrote 8. 71 degrees. Right? Make sure you answer the question that's there. Taking a look at the last couple ideas then. First idea talks about something being congruent. Congruent angles are angles that have the same measure. Maybe they both measure 40 degrees. That would make these two angles congruent. The markings we use for congruent angles are these little partial circles. That signifies that those two angles are congruent. So when I look at example 4, if they have the same number of markings, that would make them congruent. So it says identify your pairs of congruent angles. Well, angle P has a single arc to it. It is congruent to angle N because that has a single mark to it. Angle L has a double mark to it. It is congruent to angle M because it has a double mark to it. So if angle P is 120 degrees, that means angle N is also 120 degrees. Last idea of the day then is the idea of what they call an angle bisector. To bisect something means you are going to cut it in half. To be an angle bisector then, you are going to divide an angle into two congruent parts. So an angle bisector is a ray that divides an angle into two congruent angles. Which brings us to our last problem. In example 5, it says, in the diagram, ray WY bisects angle XWZ. So this ray cuts my angle into two equal pieces. This piece here and this piece here has to be the same. It says angle XWY is 29 degrees. So if this angle is 29 degrees, that means this angle is 29 degrees. Angle YWZ. They want you to find the measure of angle XWZ then. Angle XWZ. That is our big angle there. So I have to take my 29 plus my other 29 degrees to get a total of 58 degrees. That is the measure of our big angle. All right, here you see your homework for tonight. Page 29, numbers 22 to 27. And page 30, numbers 29 to 31. And then 33 to 42. But you can skip numbers 39. All right, if you have questions, please let me know.